It was super hard. Oh my God. Whew.
Okay. Now we start recording. Yes, it is.
Okay, so do I start now?
No. Let me now share the screen with the presentation on it. So share screen. Okay. Again, now you guys see what's in front of me on the screen, right?
1 second, let's see. Yeah, you need to go to the presentation.
That's what I'm trying to find. You know what? Let me just open up Google.
Do you guys hear me?
Yeah, we hear you.
Okay, good. Because I thought my mic doesn't work when I go to different. All right, here we go.
Okay, so
Wait, when I tell you press present, you gotta. All right,
wait,
let me pull it up here. Oh my God, I don't know how this is gonna be 10 minutes. I made mine super long though. If y'all see the first 6 slides,
Mhm.
it just added like so much more.
just try to like add
Yeah, I'm gonna be
by
like
yourself,
Nawaf.
like as if you were in a class and we were just a bunch of idiots. You want to explain every single little
Yeah,
thing.
I'm gonna be like Nawaf because I have to go slow as hell to get 10 minutes.
Yeah, plus I like keep explaining the words because
Bro,
the
I looked at Raed's presentation that you sent me, Majid. It's 8 slides and
Yeah.
he like barely has anything on it. I don't know how he's gonna get 10 minutes.
Because
So
he always puts so little on the slides, then he talks a lot about it in his head.
yeah,
Or
that's
like,
true. That's how he does it. All right,
so let's go.
all right. 3, 2, 1, present. All right. So the knowledge question: to what extent can we trust? Oh, hold up. Sorry, I gotta start a 10-minute stopwatch. All right. I'm about to start. Can y'all hear me?
Wait, is there any
Yeah.
slide in front of you guys that says it's recording?
Yeah, it's recording.
Yeah.
Okay, just jump.
Oh my God, my phone's on. All right, 10%. I gotta go quick. All right. So, knowledge question: to what extent can we trust our intuition in mathematics? By Ahmed Salim, Mujib Kohistani, and Al Hussein. All right. All right. The birthday paradox. So, what is the birthday paradox? The birthday paradox is a probability theory that concerns the probability that in a set of randomly chosen people, some pair of them will have the same birthday. So if you have like 20 people in a class, then there's like a 50% chance that 2 of them are most likely to share the same birthday. The aim of this real life situation is to explain how it works and how it relies on our intuition. Okay, so intuition. Intuition is a person's intuition in mathematics relies on their personal knowledge. So therefore, someone with more personal knowledge can trust their intuition more than someone with less. So basically, like uh, each person has like a different level of personal knowledge, and I'm gonna go through that in a different slide. The theme of this real life situation is that it's counterintuitive, and it's counterintuitive because the birthday paradox. Uh, a person wouldn't expect the percentage of people in this paradox. Uh, oh, it's not. A person would not expect the percentage of people with the same birthday to be so high. So therefore, it relies on a person's intuition. All right, next. All right. How does personal knowledge affect the reliability of intuition, specifically in mathematics? So now I'm going to say what role does personal knowledge play with intuition? So personal knowledge affects the reliability of intuition in mathematics because different people have different experiences with learning math in the past, and because of that, everyone has a different level of personal knowledge. So, for example, someone who mastered probability and statistics, like they learned it for 2 years and they already mastered the subject, it would be way easier for them to understand the birthday paradox because because they already learned about probability, so it would make way more sense compared to someone who never took probability or statistics in their life. Then they would be super confused and they wouldn't expect the number of people to be so high. And also, someone could have had certain experiences in the past, like in different classes where 2 or more people shared the same birthday. So then it wouldn't be so surprising when they hear about the birthday paradox, because then they've already like been in a similar situation. All right, next. All right, 1 second. Okay, ways of knowing. So intuition. In the birthday paradox, you use your intuition or gut feeling to tell you if you should believe the paradox or not. So intuition relies on personal knowledge, and therefore certain people trust their intuition more than others. Because like I said, uh, if you have certain personal knowledge about this about probability, then you would be able to trust your intuition more than, for example, someone who doesn't know about probability as much. So different people could trust their intuition more than others. Another WOK is imagination, because for some people, imagination can help you imagine the scenario of 20 people and the probability of having 2 people with the same birthday of 50%. So different people obviously have different levels of imagination. So yeah, and another way of knowing would be memory, because memory can relate to the personal knowledge. Like I said, if you've been in a similar situation in a class and you had 2 people with the same birthday, then you can use your memory to relate back to that scenario and understand the birthday paradox. All right. Yeah, and the sub knowledge question was, what role does intuition play in the birthday paradox? All right. Next would be areas of knowledge. All right. Obviously, the one area of knowledge in this would be mathematics, because the birthday paradox is actually like it's been tested with like classes and stuff. So I'm about to explain it. So the birthday paradox relates to math, obviously, because it involves probability. And I'm about to explain the probability that 2 people have the same birthday in probability in math. So the first person can have any birthday, so that gives him 365 possible birthdays out of 365 days. So the probability of the first person having the right birthday, you would calculate that by doing 365 over 365, which would obviously give you 100%. Now the chance that the second person has the same birthday as the first person is 1 over 365. Okay. And to find the probability that both people have this birthday, you have to multiply both probabilities. So 365 over 365 times 1 over 365 equals 1 over 365. So that's 27% that that the second person would have the same birthday as the first person. All right, next. Okay. So this relates back to the knowledge question. It's kind of like a sub-knowledge question. So should we trust our intuition in the birthday paradox? And in my opinion, we shouldn't fully trust our intuition in the birthday paradox, because our intuition would tell us that the same birthday should be a lower percentage, because you wouldn't expect the numbers to be so high for people with the same birthday. But as I already explained earlier in one of the previous slides, different people can trust their intuition more than others because they might have more or less personal knowledge than other people. So it really depends on how much personal knowledge that person has.
Okay.
Yeah. All right. It's about 9 minutes something. So yeah, I'm good.
Right. Mujib.
Yeah.
You're up. I'm about to time you if you want.
I'm gonna time myself real quick.
All right, you got it.
All right, I'm starting now. All right, this is our second real life situation, which is Zeno's paradox in 5th century BC. For those who don't know what the Zeno's paradox, it's basically a paradox that is counterintuitive, because our intuition is telling us one thing, but mathematically, it's telling us something completely different. And I'm gonna give an example so you guys can understand better. For example, if you want to get to the other side of a field, you would have to walk half the distance and then walk the half the distance again, and then walk half the remaining distance, making it an endless cycle and never reaching the end of the field. And he proves this mathematically. Well, he doesn't really prove it, obviously, because our intuition can obviously tell that we're getting closer and closer to the end of the field. How it relates to our knowledge question, this relates back to our knowledge question because our intuition tells us that eventually we'll reach the end of the field, but the math by Zeno is implying which will never reach the end. It's like a never-ending loop. Next slide. All right, the ways of knowledge used in this paradox was, the first one was a sense perception. And one of the senses we use for this one is seeing with our eyes. We use sight in this paradox, but how? Well, we use it because we travel more and more to the point we're trying to get to. So our sight clearly helps us realize that we are getting closer. So that's one way of knowing of Zeno's paradox is false, and that our intuition is a big part in it. And the second one is reason. Zeno's paradox is telling us that from point A to point B is infinite, according to his mathematical studies. However, we can argue against this because we can obviously tell point B is getting closer the more we travel towards it. We reason that we're getting closer, so in this paradox, it's unlikely that we can trust Zeno's mathematical calculations. And the third and last ways of knowing is intuition. Our gut feeling knows and understands that with every step we take, we're getting closer to point B, even though Zeno's paradox says from point A to point B is an infinite amount of time. Next slide. Areas of knowledge. Obviously, mathematics is an area of knowledge because Zeno did use mathematics to come up with this paradox, and without. Hello, do you guys hear me?
Yeah.
We hear you.
Because it just said like error or something. And without math, it wouldn't be a paradox because math is only the supporting thing to help, like the only supporting area of knowledge to help his case. And my sub-knowledge question was, to what extent can we trust mathematics and Zeno's paradox? And that sub-knowledge question actually helped me figure out a couple things in this presentation. Next slide. should we trust our intuition or mathematics more in Zeno's paradox? Well, we should obviously trust our intuition more in this situation because our gut feeling tells us that we're getting closer to point B. And also, when Zeno used math to prove his paradox, it was hard to believe because everyone has traveled from point A to point B a finite amount of time. Like it didn't take us, like it wasn't infinite. Like we obviously reached point B. So his paradox really wasn't valid, and he really just didn't prove anything, and he really just made it seem like it was never ending. But in reality, we know we would get to the other side eventually. So it's safe to say that we shouldn't trust math at all because you can just play with numbers, but you can't play with what you actually see and feel. All right, next slide.
That's,
Yo, that was 5 minutes and 30 seconds, bro.
bro, why you told the teacher that he will listen to this? Oh God. Okay, my turn. So
He said the whole presentation has to be 30 minutes. He didn't say each one has to present for 5 minutes. So whatever, keep going.
okay, so our third real life situation, we'll talk about something called Benford's law. What is Benford's law? Benford's law is a law of statistics that says if you have a random set of numbers, number 1 will appear as a leading digit more than number 2, and number 2 will appear more than 3, and number 3 will appear more than number 4, and like that. And when I said leading digit, I mean the first digit from the left. That's the leading digit of any number. Okay, this is of course counterintuitive because what everybody thinks is that all numbers should appear equally, but they don't, which is kind of make it hard to understand. It made the biggest minds on math and physics don't understand it. The ways of knowing that associates with Benford's law is memory, because memory is a very, very big factor in intuition. And memory, what tells us what's normal and what's not. So for example, okay. So for example, 200 years ago, people didn't used to find the police walking on the street and stop them giving them a ticket because they parked wrong. Something like this is like they never expected that would ever happen. But now it's really normal to drive on the street and police stops you, give you a ticket, and have some authority on you. And imagination. I think the imagination affects someone's intuition because if you have a strong imagination, counterintuitive stuff would be a little easier to understand than someone who doesn't have a really strong imagination. For example, a lot of things about space have been discovered through using imagination, and it was easier for the people who had strong imagination to discover it. And the areas of knowledge that associates with Benford's law is, of course, mathematics, because Benford's law is lost in statistics, and it uses logarithmic functions to write the equations for this law. So, of course, it relates to mathematics. Okay, now I want to discuss how does intuition make it a little bit hard for us to understand Benford's law. So, as I said, we all expect that when we have a random set of number 1 will appear as number 2, and number 2 will appear as many times as number 3, and so on. But that's not the case. Number 1 appears with a specific percent every single time. Number 2 will appear with a very specific percent every single time. And number 1 will be more than number 2, and so on. So that was a little bit counterintuitive. Even the guy who discovered this and wrote the equation He didn't even understand what this equation meant. He just found out that this equation worked. That was it. It took a really long time to fully understand Benford's law. And I will give you another example. Let's say I did not go to the next TOK class. So our TOK teacher asked us why I wasn't here. But that's not it. Let's say our TOK teacher is from another planet. So the intuition that we have, he doesn't have. He have a different intuition, draw from a different memory from another planet. And when he asked me why I didn't come to the class, I told him, well, my sister fell from the stairs. Then he asked me, how does that have anything to do with like our class? Like, why does that matter? So I told her leg broke. Then maybe in their blindness they doesn't have any like breaking bones or anything like that, so he didn't get it. See, intuition played role in that. So I had to explain to him everything from the beginning. But if he was a teacher from our planet, normally he would understand everything and he would even feel sorry for me. So that plays a role. And to what extent does intuition and religion contradict with each other? So I think most of the time a religion contradict with intuition. For example, story like Adam and Eve and how they came to earth and how they were in heaven first and how did all these stuff happen kind of contradict with science and our intuition and our memory, especially that we've never seen something like that happen before with our eyes. That relates again to the memory. We don't remember seeing anything like this happen, and like people flying from the sky come to the earth, or someone went to heaven and come back, or like a devil talking to you, like, or like anything like this. So that's how intuition contradict with religion. And
Wait, are you done?
yep,
All right. Do you know how long that was?
totally to 21 minutes.
Wait, okay. So I have a conclusion. Obviously. So in conclusion, we were able to use the three different real life situations: birthday paradox, Zeno's paradox, and Benford's law, to determine how we can use our intuition to see if they're true or not. And we came up with different opinions. So for the birthday paradox, we learned that it ultimately depends on a person's intuition, because each person has a different level of intuition because they have a different level of personal knowledge. On the other hand, we learned that Zeno's paradox, we should definitely trust our intuition because our gut feeling is what's helping us know if we're getting closer to point B. And lastly, for Benford's law, we learned that intuition can be misleading if someone doesn't fully understand the topic. So it also relies on our personal knowledge.
Mm-hmm.
So yeah, that's all I have. All right, you could end it, I think.
Okay. So now we're done. So let's just.
You could stop recording and then. But wait, do you know how you're gonna be able to like cut this and copy it on YouTube and all that? Or
Yeah, I think he knows, bro.
because if not, if you end this thing without knowing how to do that, then we just wasted 30 minutes for no reason.
Not really, but let's see.
I mean, we just presented, so.
I'll just press stop recording.
Okay.
Yeah, and then it goes to your photos automatically, and then you just go